Okay, today we are going to find the sums of n terms of arithmetic series. Yesterday, what did we look at? Arithmetic sequences. Today we're looking at series. So that means there must be a difference between a sequence and a series. Anybody know what the...
It's not just atoms and stuff.
Nope.
Series of numbers. Multiple. What do you ask?
What's the difference between a sequence and a series? What word is up there in that learning goal that wasn't up there yesterday besides
Series.
sum? So a series is when I take a sequence and I add the terms up. That's the difference between a series and a sequence. Sequence is just the terms. A series is when I add the terms up. That's the difference between a series and a sequence. Okay? So today we're interested in finding sums of the arithmetic series, or sums of the sequences. Alright, so it looks like we have 4 examples. So 53 plus 31 plus 9 plus ... and we want to find the 17th sum.
So that means you're going to add all those to the 17.
That is correct. So the 17th sum means I want to take the first 17 numbers and add those up. Okay? So obviously we're not going to write them out 17 times and then add them up. So what do you think we need?
Formula.
We need a formula. And there are 2 different formulas we're going to use today. Alright, the first formula is S sub n equals n over 2 times a sub 1 plus a sub n. S sub n equals n over 2 times a sub 1 plus a sub n. So what does S sub n represent? Sum. What does n represent? Number of terms. A sub 1 is the first term, and a sub n is the last term. Okay. So there's that one. The other one is S sub n equals n over 2, 2 times a sub 1 plus n minus 1 times the common difference. So again, S sub n represents the sum, n represents the number of terms, a sub 1 is the first term, n is still the number of terms, and d is the common difference. So let's discuss, when do I use one over the other?
When you don't have A of n,
Okay, when I don't have A of n, that tells me what?
you use the other one.
I use the second one if I don't have A of n. Okay, what does A of n represent?
The last one.
The last term. So if I have the last term, I want to use the first one. If I don't have the last term, I want to use the second one. Yes.
So does A of n equal n minus 1 b?
No.
Okay.
It's A of n, if you plug in yesterday's formula for A of n and work it out, this is what you end up with. Does that make sense? So if I take yesterday's formula, I plug it in here, and then clean it up, I'm going to end up with this formula.
Okay.
Alright, so on this current one I'm working with, the current series I'm working with, which one of those 2 formulas do I want to use? The first one or the second one?
Second.
I want to use the second one. Okay, so I'm going to have S sub 17. Why am I putting 17 there?
Because
That's the number of terms, is 17. Alright, so then I have 17 over 2. 2 times a sub 1, which is 53, plus 17 minus 1, times my common difference. What's my common difference? Negative 22. And then I punch that in my calculator. When I do so, I get this sum to be negative 2,091. So what does negative 2,091 represent?
The 17.
the sum.
The sum of those numbers.
The sum of those 17 terms added up. That's what I would get, is negative 2091. Negative 22,
Oh,
Yeah.
Where'd you get negative 22?
I did the second term minus the first term.
Oh,
The common difference. Second term minus the first term. Alright, there's example number 1. And example number 2, I have negative 5 plus 2 plus 9 plus dot 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 plus 317.
You did the first one because we know A and so then.
The first one because I have a sub n, that is correct. But what do I not know right now?
You don't know what number you're looking
How many terms?
I don't know how many terms there are. So how do I find out how many terms there are?
Solve for n.
Solve for n. In what? What do you mean? From what? From yesterday, that is correct. Very good, Natasha. So I need to go back to yesterday's formula, which is this, and I need to use this formula to help me find n. So what do I plug in for a sub n? 317. I plug in negative 5. N is what I'm looking for, and my common difference is negative 22. So now I can solve this for n. Oh, yeah, that was the last problem, wasn't it?
Yeah. I was about to say, maybe it's just.
Alright, so it is 7. Alright, so I add 5 over, gives me 322. N minus 1 times 7. I divide by 7, what does that give me? 46. And add 1 gives me 47. So what do we figure out with 47?
So that 317 is the 47th.
317 is the 47th term, that is correct. So there are 47 terms in this series. And I punch that in my calculator, we end up with 7,332. What does 7,332 represent? The sum of how many terms? 47 terms. If I were to add those 47 terms up, I'd get 7,332.
So the number's always gonna be that big.
No. All right. Now we're going to put something on the board that looks a little bit different. You probably have seen it before.
That's amazing.
Anybody know what this thing is?
Oh.
That's
Exactly. Yeah. When I go look this up, it's a zero, I swear. I know some of it. My mom.
This is summation notation, and that character is called sigma.
Sigma. Thank you.
Okay, so this is summation notation, and that character is called sigma. And what this is this is a series that is stored in summation notation. So this right here represents a series. It's just stored differently. Okay, so we need to find out what series is stored inside of this summation notation. So does anybody know what to do to find the series that's stored inside of it?
what is I?
I had to mention.
Okay, what you do is you start by plugging in the number that's on the bottom. So I'm going to plug 6 in for I. So if I plug 6 in for I, that is 30 minus 17, which gives me 13. So that means 13 is the first term in this series. Love it. I plug 6 in for I. 5 times 6 is 30. 30 minus 17 give me 13. To get the next term, you increase what you plugged in by 1. So I plugged in 6 the first time. I'm going to plug in 7 the second time. So 7 times 5 is 35. 35 minus 17 gives me 18. Okay, and Natasha's already noticing something. What? What's the question? So then what would I plug in the next time? 8. I plug in 8, which gives me 40, and 40 minus 17 gives me 23. So you can kind of see.
So if we just do it twice and then find the common difference, we just do it by that.
Well, yes, eventually. Okay. Now, you continue doing this until what you're plugging in is 28. So I plugged in 6, I plugged in 7, I plugged in 8. I keep plugging in until the last thing I plug in is 28. So let's go ahead and plug in 28. So 28 times 5 is 140, and then 140 minus 17 gives me 123. So that summation, this summation notation represents this series right here. Okay, so it's another way of representing the series. So which formula do I want to use to find the sum of this series? Okay, why? I want to use the first one because I have the last term. Good. Say it again.
So the top one is just like.
I plug the top one in. It's not in. I plugged the top one in to get the last term. You were correct on that. But it's not in. So 13 plus 123, and I'm missing the n. I'm still missing the n. You might think it's 28 minus 6, but it's not. So let's plug it into the formula we did just a while ago on the last problem to figure out what n is. So if I plug it in here, what am I going to plug in for a sub n? 123. I plug in 13. N is what I'm looking for, and my common difference is 5. So I subtract 13, gives me 110. I divide by 5, which gives me 22. And I add 1 gives me 23. So, Kurt, go back and adjust what you thought it would be.
You add 1 because you have to include 6.
There you go. So, to get in, all you do is subtract 28 and 6 and then add 1 to it. So, you don't have to go through this over here, but we wanted to go through it to figure out what it was. Now we figure out it's 23. All I have to do is subtract and then add 1 to get my n. So 28 minus 6 is 22. Add 1 gives me 23. Okay.
Is it a coincidence that that 5 before the I is 28 minus 5 is 23?
Say that again.
28 minus 5 is 23. Is that a coincidence that
Yes.
that equals n? Okay.
That's a coincidence. All right. So this ends up being 1,564. Yes.
Can you repeat how you got it the easy way? How you got 23?
You subtract these two numbers and add 1 to it. All right. One more. All right, so this time my summation notation, I start by plugging in 12, and then the last thing I plug in is 18, and I want to find the sum of this series. So what do I need to find the sum of this series?
Plug in.
I need the first term, I need the last term, and I need
In.
n. Okay, so let's start with n. What is n going to be? N is 7. Why is it 7, Kendrick?
Because you subtract the first term and the last term. I mean, not the first term, but the one on top.
So I subtract these two and
Add one.
add 1. So there's n. Okay, then I need a sub 1. What do I do to get a sub 1? I plug in 12. So if I plug in 12, that's negative 24. Negative 24 plus 57 is 33?
Yeah.
Alright, then what else do I need? I need the last term, which is a sub 7, and how do I get the last term?
Plug 18.
I plug the top number in, so I plug 18 in. If I plug 18 in, that's negative 36 plus 57, which gives me 21, correct?
No.
Now I've got everything I need to use the first formula over there. So I want the 7th partial sum of 7 over 2. A sub 1 is 33 plus 21. I punch that in, and we end up with 189. So how many terms did we add up to get 189? 7 terms. And how far apart was each term? Anybody know how far apart each term was?
2.
2. How'd you get that?
I put them off to the side of the list and just noticed it.
What do you mean? You found a few terms?
Yeah, I did the 12, 13, 14.
So you
nothing
plugged in
special.
12, you plugged in 13. Okay, and it should have been a negative 2, right?
You're right.
Did they
It's
decrease?
Yeah.
Does anybody see how we got negative 2?
If it's decreasing, it's negative.
That right there tells me. Because look at the previous one. What's in that spot?
5.
5, and how far apart were each number?
Huh.
Each number was 5 apart.
Could you explain
It
that?
ain't weird at all.
When we acknowledge it.
I plugged 18 in there.
Oh, okay.
That's the number. Yeah, we know.
Oh, that's the 18 minus negative 2.
18 times negative 2.
Oh, times.
The 7,
No, minus.
the 7 came from this.
Right.
Okay, so if it may be confusing you. If I do this, is that better?
Yes, that was
Okay.
tremendously better.
Good. But again, what is n?
7.
N is 7, so that's why I put 7.
Okay.
So that's what so it's 18.
Say it again.
Okay, you got the first term,
I plug 12 in,
and then you got the same term plugged in 18.
plug it in 18.
Okay.
Alright, so page 605. We're going to do 40 to 56 even. Now I want you to look at 46, 48, 50, and 52. Those are the summation notations, but I want you to notice how they've written them because I do not like how they've written them. Because what variable did they use? N. Why do I not like them using N? Because what is already in our formulas? N, and the N that is in that summation notation is not the same N that's in our formula. So if I'm you, when you write those summation notations down, I would put I in it like I did, or some other variable. Okay? Because when you use N in a summation notation, and you use N in these formulas, you get confused on which N is which N. So I would, when you write those down, I would change those to I or K or J or something like that.